Welcome to Coach Eichner's Math. Today we are going to start talking about angles. First thing we need to do is make sure we got some terms clear. As we talk about angles, the first term we want to talk about is rays. Rays are objects consisting of one or more endpoint and continuously infinite endpoints in one direction. We should already know what this looks like. We've got one endpoint and it goes on forever in one direction. I could label that AB, and we would call that ray AB. Now, looking at angles, an angle is an object consisting of two rays, called sides, with a common endpoint called a vertex. So if I want to just add on to my prior picture, I've got one ray AB. I'm going to go ahead and have a second ray because we're going to have a common endpoint. Second ray off of there, and we're going to call it ray AC. So I have ray AB and ray AC, which come together to make angle BAC. Now notice the middle of my angle is always going to be my vertex when I'm listing my points on my angle. So looking at the following, name each of the following. For example 1. Sides. We have two sides. Again, our sides are rays. It is ray BA and ray BC. Remember, on rays, we must start with our endpoint. The vertex is the point in the middle, our common endpoint, otherwise known as point B. The name for our angle. I could call it angle B, or I could call it angle ABC. The important part here is I can call it angle B and only use one letter. The only time I can't do that is looking at example 2, because now I have two angles that I could call angle P. So I have to be more specific. It's kind of like having a first and last name. It's only important when there's somebody else in the same area so that you could end up getting confused. So look at example 2. How does the diagram in example 1 differ from the example in 2? We've already talked about that. We've got two angles instead of one. We've got one angle, two angles. Okay, so those two angles I would name angle SPR and angle RPQ. Notice they share the letters R and the letters Q, or letters P, but because they're in different spots, they have different third letter, S and Q. Again, we use three letters, kind of like we use a first and last name if we have more than one person with the same name, which would be vertex of P. Looking down below, an angle separates into three distinct parts. You can be inside an angle, which would be like where I wrote the 1 and the 2. You can be outside an angle, which would be any area out here beyond the perimeter of my sides, or I could be on an angle. And what it means to be on an angle is any of those points that we've already named are considered on the angle because they are on my ray. Point S, point P, point R, and point Q are all on an angle. Moving on. Looking at example 3. Part A says name a point in the interior of angle QPS in example 2. Well, let's look back at the interior. QPS is the large angle here, which means that anything inside of it would be considered interior. Point R would be on the inside. So in part A, we're going to say that point R is on the inside of angle QPS. Part B. Name a point on the exterior of QPR in example 2. Well, looking at the first example, QPR in example 2, looking for something on the exterior. Exterior is another way to say outside. So outside of that would be point S. So we're going to say that point S is on the exterior of angle QPR in example 2. Adjacent angles. Our next term, angles that have a common vertex and side, but no common interior points. So adjacent angles, we can use our picture that we just had from the previous side. They share a common endpoint, common vertex, and a common side. That makes these two angles adjacent. However, there's no part of those angles that is shared besides the vertex and the side. So anytime we have adjacent angles, shared vertex, shared side. Two smaller angles in example 2 are adjacent angles. The diagram in example 2 suggests the following postulate. Again, just like the segment addition postulate, we have the angle addition postulate. All it is a fancy way to say part plus part equals whole. If R is in the interior of QPS, then QPR and RPS must equal QPS. All it says is part plus part equals the whole. Again, that's going to be really important as we head forward. So looking down at example number 4. Example number 4 says measure of angle PQS equals 77 degrees. PQS would be the whole angle. So the whole angle is 77 degrees. I know that PQR, this piece, would be 32 degrees. Find the missing piece. So I know one part is 32 degrees. I know that my second part is the measure of angle RQS. And that's got to equal 77 degrees because 77 is my whole. Notice as I'm doing this, I'm putting my finger or my pen on each point as I'm reading them above. So to figure out what the measure of angle RQS is, I'm going to subtract 32 from both sides, and you'll find that 45 degrees is the measure of that angle. Now degrees are what we talk about. It's kind of like inches or centimeters. It is our unit of measure, so please make sure that you're adding that degree sign anytime we are talking about angles. Moving on, example number 5. My suggestion is you try this yourself. I'll give you just a couple minutes. Go ahead and try this. Push pause on your video, try it, and then check your answers. All right, example 5. If the measure of angle AOC, the whole, I'm going to go ahead and write it out for you, part plus part equals whole. If the whole is 70 degrees, and the measure of angle AOB is x plus 10, that's part number 1, and the measure of angle BOC is x, what is the value of x? And then we're going to find both pieces. So I would say that's 2x, because I'm going to combine my x's, plus 10 equals 70. So I'm going to subtract 10 from both sides, and we'll say that 2x equals 60. Divide by 2. Tell me that x equals 30 degrees. Okay, so now that we know that x is 30 degrees, if I want to find the measure of angle BOC, well, that's just x. We're going to write down 30 degrees. The measure of angle AOB, it's x plus 10. Well, we know that x is 30, so 30 plus 10 is 40 degrees. Angles can be classified in a couple different ways. If an angle has a degree measure of less than 90 degrees, it would be classified as acute. If an angle has a degree measure equal to 90 degrees, it is classified as right. If an angle has a degree measure greater than 90 degrees, it is classified as obtuse. And if an angle has a degree measure of equal to 180 degrees, it is classified as straight. Now, straight angles are also known by another name, because in order to be an angle we have to have an endpoint and two sides. Well, an endpoint with side 1 and side 2, well, notice those rays, my two sides, go in opposite directions, which not only makes this a straight angle, it is also an opposite ray. Okay. Looking down at number 6. For each of the following angles, A, name it. B, tell whether the measure is less than 90, greater than 90, equal to 90, or equal to 180. And C, classify it. So, naming the angle. We're going to say that this could be angle YFI, or I could say it's angle, because there's only one angle. We're going to name it off the vertex, angle F. The measure is 35 degrees. Okay, so the measure is 35 degrees, and the measure is then less than 90 degrees. Since it's less than 90 degrees, it would be an acute angle. So, looking on to the next part. First thing, we're going to name it. This is angle LTC, otherwise known as angle T for the vertex. The measure is 125 degrees. It is more than or greater than 90 degrees. And since it is greater than 90 degrees, we're going to call it an obtuse angle. So, I'm going to give you just a minute. I want you to try the next two on your own. Please pause the video now. Go ahead and try these. And then see if your answers match up. All right, let's look at them. Next one, we're going to name it. We're going to say angle RTS or angle T. The measure is 90 degrees. I know this because of that little right angle right there. It is equal to 90 degrees, which I already ruined it for you. It is going to be a right angle. Looking at the next one, we've got angle NXS or angle X. The measure has to be 180 degrees because it looks like a line. Because it looks like a line, we're going to say it equals 180. Well, that's just a straight angle, which is also known as a line or a ray, depending on how you want to name it. But when we're talking about angles, we're worried about how many degrees, which is 180. So we're going to go ahead and call it a straight angle. So, when angles have the same measure,